Hello everyone, today we're looking at another Leetcode problem. This is 3333, which is find the original type string number 2. This is the second problem in its series. This is a hard problem. We have solved the first problem yesterday, so I will have the link attached in the description and feel free to review that if you like. So now in this problem, Alice is typing some characters and she accidentally types or no, or presses the character button a little longer. So there's a long press which, let's say she was planning to write X, because of the long press it leads to few duplicates. Now this is unintentional. Okay, but in some cases they can be intentional duplicates. This is intentional, but in some cases they can be unintentional ones. Now we are given the word which is the final output, and we don't know like which of the repeating characters in this final output are actually intentional and non-intentional. Along with the word, we are also given a positive integer value k. Now what we have to do is we have to return the total number of strings that Alice might have intended to type when she was trying to type a string of size at least k. There can be a lot of the number of possibilities can be very huge, so we have to return modulo 10 power 9 plus 7. Okay, so let's recap this problem a little bit, right? Let's say my input string is AABB, and let's say Alice intended to type a string of size k, which in this example is 4 or greater than 4. So let's look at the index, which means our length is equal to 5. So now there are two possibilities for sizes greater than or equal to k. One is the original string as it is, which is of size 5. The other possibility is to have size of 4. Okay, and that's about it, because we want greater than or equal to 4, so you get 4 or upward. Okay, now what does these different possibilities mean, right? Now let's talk about that. So if this particular thing had a mistake, what would that be like? Let's say Alice wanted to type just a single A. So rest of the two A's are unintentional. So one possibility is A. Let's say Alice just wanted to type AA. So that means the third A is unintentional. Okay, and the third option is, let's say Alice wanted to type all the characters AAA. So we got three possibilities here. Now let's do that for B as well. Let's say Alice intended to write just B. That's one possibility. Let's say Alice intended to write BB. That's a second possibility. So we get 2 here. Now in the last problem, we just had to look at one mistake which could happen. So we did an addition. But in this case, there can be addition in multiple groups. So they could be errors in multiple groups. So we have to now look at all of the possibilities in totality. So what that means is, starting from nothing, there are three possibilities of A. You take A, you take AA, you take AAA. Now from here, after you've taken A, AA and AAA, you have two other possibilities. You can have single B, you can have double B. Same way, single B, double B, single B, and double B. Now all of this leads to total number of possibilities. Like for example, if you trace this path, you will get AB. If you trace this path, you will get ABB. And if you trace this path, you get AAB, AABB, and so on. Okay, so this will be A, then A, B, and this is the actual input string that we got. So these are the 6 possibilities that we can have, which is our total. That's the max that we can have. Now in this total, what we are saying is that if this is length, which is the total length, which in this case happens to be 5, there is k somewhere here, which happens to be 4. I need to count how many of them are greater than or equal to 4. So there are some numbers which are going to have size 4, then they're going to be, in this case, just 4 and 5. So there is 3, 2, 1 here. Okay, so like 2 would be AB and so on. 3 would be ABB and so on. So what we need to do is find this set of possibilities. Now, before we proceed on this, let us quickly look at the constraints that they've given us. Now, the word length is the maximum value of the length or the maximum length of the word can be 5 into 10 power 5. Okay, and the maximum value that k can take is around 2000, so 2 into 10 power 3. So this range is actually quite big, and so instead of trying to find all the variations in this range, which is going to be quite expensive, why don't we focus on this side of the range? Okay, because this is a smaller set. Its max is going to be 10 power 3, and so once we find this set, we can subtract it from the total. So we already know the total here, right? Calculating the total was quite easy. You take all of the frequencies of the groups and then you multiply them. And why are we taking the frequencies and multiplying? That is what we discussed here. So once you do 3 into 2, you get all of, you're basically talking about all of these variations, and which is going to be this total of 6. Now from this 6, if we subtract a smaller set of possibilities, then we are left with the actual possibility count that we are interested in. Okay, so this is what we are going to do. Now let's now focus on how are we going to find this set. Okay, so let's clean it up a little bit and just rewrite what are we talking about here. So we are talking about counting. So what we're going to do is we are going to be counting. What are we counting? We want to count number of possibilities, number of, let's say, strings possible of length equal to 1 plus number of strings possible of length equal to 2 plus number of strings possible of length equal to k minus 1. Okay, so this is the count of the left hand side of the set that we want to find. And if we subtract that from total, we are going to get number of possibilities of strings which have length greater than or equal to k. That's what we are going to be getting. Okay, so far so good. Now let's think about how are we going to do this counting, because there are we are talking about different groups. There are multiple groups of different lengths. So in each group we have to think about variable lengths, and then all of that has to come together to create a string of some expected output value. So we are especially focusing on these values, right? So this is what we want to count. So we want to specifically count strings that lead to this. Okay, so before we get into that, now let's talk a little bit about the counting part. Like, how do I create a new string? So let's say I have previously seen some groups. So let's have some dot dot dot, and then I'm looking at AAA. Okay, and now what I'm saying is that I am expecting to compute or to count how many strings can I have of length I. So this is what I'm trying to count. Okay, how many strings can I have of length I, which means my output length has to be I. Now we know that AAA has three possibilities. I could have written just A, I could have written just AAA, or I could have written just, I could have written just A, I could have written just AA, or I could have written AAA. So what that means is that if I'm using A, I'm starting from I minus 1. Okay, I'm starting from a string of length I minus 1, and I'm adding one extra character of A and getting to a string of length I. Same way, if I need to get to a string of length I using AA, then I have to look at all the strings that have length of I minus 2. Same way, for the third one, AAA, I have to start from strings that had length of I minus 3. Now, if as I was processing all of this, these lengths are known to me because I have already processed and then I've come to this state. Either I am at the initialization state, so all of these values are 0, not all, one or some are 0, or they are already computed and I have some value to it. But the main point is that I need to sum these values. What does that mean? I need to sum how many strings did I have of length I minus 1, how many strings did I have of length I minus 2, how many strings did I have of length I minus 3, to totally give me the number of strings that I can create of length I using this. Okay, so all of this to give me total, or let's say number of strings I can create of length equal to I using AAA. We can create strings of length I using some other groups as well, but here we are only counting how, like what can we create using AAA. And then this whole operation that we are doing for, let's say, group X, which was AAA, I will repeat this for all the other groups and I will keep counting. Okay, and so what that is going to give me is, let's say, an array where 0 represents how many strings can I have of length 0, how many strings can I have of length 1, how many strings can I have of length 2, and so on. And this is what I'm filling. This thing I'm filling x times, where, or let's call it m times, where m represents the number of groups that I have. Okay, so thereby I'm building this. Okay, so now let's see what so in terms of the addition, I think, or the operation that we are doing, I think that makes sense. Now let us talk about an optimization, which is quite a useful one to do. So what happens here is If I have to efficiently compute, let's first put it on a number line, right? So this is I, which I'm trying to compute. This is I minus 1, this is I minus 2, and this is I minus 3. Okay, and now what I'm saying is this has some value x1. Let's say this has some value, let's say v1, v2, v3. Okay, I want to sum these values up. Now, sometimes these sums can be really large because you can have a very long group as well. If you remember, the length of the word is 5 into 10 to the power 5. So some groups can be really large. So in order for us to optimize and make this addition efficient, we can use pre-sum as a concept. Okay, what that means is I will now have another pre-sum array which has at I plus 1 has the sum of all of all of this until I plus 1. And at I minus 2, it has all the sum until I minus 2. At I minus 3, it has all the sum until I minus 3. And so, now if I want the sum of I minus 1, I minus 2, and I minus 3, what I can do is, in my pre-sum, I can just take I minus 1 minus I minus 4. So from here, let's say I subtract this part, so it eliminates everything else and just gives me value of this. So even with indices, if you see, I minus 1 plus I, uh, minus I plus 4 gives me 3. So it gives me the value for these 3. Okay, so this is what we are going to do again and again. So what we are going to do is we're going to start with a base, let's say a base counter array. Okay, let's call this a counter array, which just gives me the number of strings at every index of length. Okay, at at that particular index. That's all this gives me. And then this is this is what I get. And to build this, I use a pre-sum array, which is an optimization. All right. So now let us talk a little bit more about how this execution will happen. Okay. So initially, let me call this DP, because here we are able to solve the problem using the subproblems where I am able to generate the ith index using the previous indices. Okay, so let's start. Let's have dp of length equal to k. Why of size k? Because what we are doing is we are keeping how many, we are basically counting, right? How many strings of len equal to 0, how many strings of length equal to 1, and so this would be how many of length equal to k minus 1. That is what this array is gonna represent. Now, before we have started our computation, what we are saying we're going to initialize this dp with is 1 on the 0th place, and rest all can be filled with 0. What does that mean? What that means here is how many ways can I make a string of length 0 without picking any of the groups. Okay, without picking any groups. So that is going to be 1. And this is also an important initialization state for us, I'll show you in the code, because if we don't have our one here, if we don't have any state value, if all of them are set as 0, I'm not going to be able to count and grow the number, and so all of the computation will just fail. So this is our initial state, which is quite important. Next, from this, we are computing a prefix sum array. Okay, the prefix sum array, if you see, is nothing but how many strings until here, the total number of strings, cumulative number of strings until here, which is 1. How many strings are here? That is also 1. And so on. So by default, we can just initialize um, an array of size k and the default value being 1. That's our initial state. And then what we do is we try to do that operation that I told you, right? Let's say if you're trying to look at if you're trying to compute a string of length strlen, then what we will try to do is we will look for, in our prefix sum, we will look for strlen minus 1. Let's say this is my strlen, because we start with at least one character, so minus 1, and then we have multiple, and that can be something like this. Okay, so what we do is the subtraction, right? So this value, prefix sum of this value minus prefix sum of 1 before that, so this and 1 before that, 1 before the last value. So that's what we do, that's the operation that we do, and this will give us a value that we can update in our DP, and then so this is all of the value that we got from group 1. Using this, we will update our prefix sum, and then we will go from group 2 and compute like this again, and then update our prefix sum, and so on. And by the time we are done, our prefix sum, which has the cumulative value, okay, the last value of this prefix sum will give us the total value to subtract, which is of the left group. Alright, so this is all about the logic. We can now look at the pseudocode because I'm going to write it on using a pen, but if you implement this, it will work for you as a solution. So def possible string, string count. So in this method, I got word, which is of type str. I got k, which is of type int, and what I need to return is a count. So I will just have type int here. Now my n, which is equal to len of word, and mod, which we must not forget. Alright, and frequency array. Now frequency array is important because we need to compute the total number of possibilities. Remember the 3 into 2 that I did. Second thing is, as we iterate through every group, we should know how many characters are possible from that group and then find this total. So let's start with counting a frequency. So count is equal to 1 for index in range 1 to n if word of index minus 1 is equal to word at index. What that means is, I'm seeing a duplicate, you increment the count. Now when we see a new number, that means that the previous count has completed, and we can add it to our frequency counter list and reset our counter. Now there is a possibility, let's say you were counting xxx, which you counted to 3. Now when you came to a, in your frequency list you added 3. But let's say these were also duplicates, so you got 1, 2, 3. Now when the iteration has ended, this 3 we should not forget to add. So after this iteration has ended, we should go ahead and add it to the frequency. Even if it was a single digit, this count, because it is getting updated only when I see the next character, the decision is being made only on the next different character or the end of loop, will not get missed. Alright, so once we have computed our frequency array, now we can talk about the total number of possibilities. So let me say total is equal to 1, and for f in frequency, what we have to do is just keep multiplying them. So total into f, this is the total number of possibilities that we can have. In case my k happens to be less than the length of frequency, okay, so let's say I had AAA, BBB, and CCC. Okay, so my frequency list is going to be 3, 3, 3. Okay, and my k is equal to 2. Okay, so here I have 3 uniques. Okay, which is A, B, and C. And I have to take these elements, right? Like at the very least, I can have A, I can have B. So we know that Alice has not made a mistake in terms of the first character press, but it's just that when she presses a certain character, she is sometimes accidentally giving a long press, which results in duplicates. Okay, so I cannot just pick AB or BC or AC. I need to pick all of them. Okay, so I cannot do 2 or any number smaller than that. I have to do at the minimum 3, and then I can go further from that. So simply return all of the possibilities. So if k happens to be lesser than or equal to len of frequency, then I can return total, but don't forget to mod it. Now this is done. Alright, so now we come to our second part where we have to start generating strings of length 1, 2, 3 up till k minus 1. Okay, so for that, if you want, you can initialize this of length. Okay, let me write the pseudocode. Okay, so let's say this is 0 for dash in range of k, and then dp of 0 is 1, because we're saying there is one way to pick string of length 0 without using any groups. Okay, so that's this. And then my prefix sum for this, the cumulative value for this is just 111. So I can just write this as 1. Okay, and next we start our logic for group id, group index, comma, group len, or the frequency in enumerate of frequency. What we do is we initialize a new dp. So what you can also call this a dp of new and reset it, but it's totally fine if you skip this part, because we're going to be, for current dp, for current group that we are building, we will only look at presum. So we assume this value, create this presum, and you can safely discard this value. Instead of using two variables tp new and dp, I'm just going to use tp, which I'm going to initialize here. Now for strlen in range of 1 comma k. Okay, so this is where the magic is going to happen. For this, we know that if there is a group we are seeing, it means there is at least one character in it, right? So let's say the upper limit for my indexing on prefix is actually, the upper limit is going to be strlen -1. So there is at least one character that I have seen. What is the lower limit? The lower limit will be equal to string len. Remember, let me go back to that value. So if this was string len, this was string len -1, and if we had, let's say, 1, 2, 3, or let's say 4 characters repeat a, then this is -1, -2, -3, -4, and then what we want to do is get to this position, which is str of len -1, 1, 2, 3, 4, -4, -1, because we want to go back to this value before strlen -4. Okay, so that's my lower limit. So I want to take my lower limit, which is going to be prefix underscore sum underscore sum of strlen minus group len -1. Now this can go out of bound, so we have to make sure that it is not out of bound. So we will take this if strlen minus group len -1 is greater than or equal to 0. Else I will take 0. That means from upper limit we don't subtract any lower limit. Alright, so my dp of this particular value strlen is going to be upper limit minus lower limit. We have computed this for one of the groups, and then so all of this happened for a single group. This outer loop, make sure that we do this for every group. Now before we go to the next group, there's some more work for us to do. See, the group is relying on the prefix sum, which is what is the total number of string lengths that we have counted until the previous group. So that needs to be updated with the current counts that we got. So let's reset our prefix sum and count again. Okay, let's say my prefix sum, we can just override it. So what we can say is the 0th index is equal to dp of 0. dp of 0 was 0. Why is that? Because now there is no way we can form a string of length 0 by picking something from a group. Now we are processing the group, right? So we have to pick at least one element. So we take this and then we say for I in range of 1 comma k, my prefix sum of index I is nothing but whatever was my prefix sum of I minus 1 plus, I'm going to pick a new value here. So this is a classical way to do the accumulation. That's all. And then finally we return total minus prefix sum of -1, and then don't forget to mod it. If you look at the time complexity of this, the worst case is you have no duplicates. So this particular loop is going to run for order of n times, and within that we are looping k times. So this particular loop itself gives you order of n times k. Plus we have the frequency, which is plus n. So overall time complexity, which was n times k plus n, can be written as order of n times k. That's about it for this problem. This was a pretty hard problem, I must say, but quite an interesting one. Hope you like it as well. I'll see you again with the next one. Thank you. Bye bye.